Using the parent function f of x, graph g of x using the new function rule, g of x equals -1/2 times f of the quantity x plus 1 plus 4. Looking at the graph of f of x, you may recognize this as f of x equals the square root of x. This indicates f of the quantity x plus 1 equals the square root of the quantity x plus 1, and therefore we can write g of x as g of x equals -1/2 times the square root of the quantity x plus 1 plus 4. However, the point of this question is not to graph this using technology. The point is to graph this using function transformations, which is what we will focus on. Recall if g of x is a transformation of f of x, we can write g of x in the form of g of x equals a times f of the product of b and the quantity x minus c plus d. Comparing this form to the new function rule, notice we have a equals -1/2, b, the coefficient of x, is 1, c is -1 because x minus -1 simplifies to x plus 1, and d equals +4. A equals -1/2 indicates a vertical reflection as well as a vertical compression by a factor of 1/2. B equals 1 indicates there is no horizontal stretch or compression, which indicates B does not affect the graph. C equals -1 indicates a shift left 1 unit, and D equals 4 indicates a vertical shift up 4 units. Before we perform the transformation, let's select two key points on the graph of f of x equals the square root of x. So that we have integer coefficients, let's use 0, 0, as well as 4, 2. To perform the transformation, we'll work our way from the inside out, starting with the function input of x plus 1, which indicates c equals -1, giving us a shift left 1 unit. This affects the x values. We now subtract 1 from the x values of the two key points. For 0, 0, 0 minus 1 is -1. The new point is -1, 0. And for 4, 2, 4 minus 1 is 3. The new point is 3, 2. This is the graph of f of x after being shifted left 1 unit. Again, working our way from the inside out, we now have a equals -1/2, which once again gives us a vertical reflection as well as a vertical compression by a factor of 1/2. This affects the function values or y values. We now multiply the y values of the two key points by -1/2. For -1, 0, 0 times -1/2 is still 0. We still have the point -1, 0. For the point 3, 2, 2 times -1/2 is -1. The new point is 3, -1. This is the graph after f of x is shifted left 1 unit, vertically reflected, as well as vertically compressed by a factor of 1/2. And then finally, on the end, we have d equals 4. This indicates a vertical shift up 4 units. This affects the y values. We now add 4 to the y values of the two key points. For -1, 0, 0 plus 4 is 4. The new ordered pair is -1, 4. And for the point 3, -1, -1 plus 4 is 3. The new point is 3, 3. This is the final transformation, which indicates this is the graph of g of x. I hope you found this helpful.